Ah, kids. All right, all right. Let's talk about some momentum. So, momentum, mass, velocity. We are talking velocity, not speed, because momentum is a vector. So we need to have direction, which is why we talk about velocity and not speed. Okay. Couple things. Units for momentum. This is kilograms, meters, seconds. That's it. The units do not have some other thing. It's not something, when we talk about m times a, which is a kilogram meter per second squared, we call that a Newton. Well, kilogram meter per second doesn't have a special name, so it's just a kilogram meter per second. Couple of other things, though. Let's see. Oh, yeah. Did I ever tell you guys about my friend Mo? I had this guy who's a really great friend from college. His name was Mo. And I'll tell you what, Mo said tons and tons of stuff. Mo talked all the time. But, the one thing I can tell you about Mo, Mo may say a lot of things, but everything that Mo says, momentum. All right. But anyway, so we have our momentum here. Honestly, momentum by itself, not that exciting. What's way, way, way more exciting is when momentum changes. So if we have a change in momentum, that's something that's way more exciting. A change in momentum is equal to a change in m times v. Now, most of the time when an object's momentum changes, its mass doesn't change. That would be like, hey, I'm going to change the momentum of this not-so-soft softball, except when I hit it with the bat, it explodes. Yeah, that typically doesn't happen. Typically, the mass doesn't change. Typically, it is the velocity that changes because, if I hit this not-so-soft softball, I change the velocity of the not-so-soft softball. So typically, it's the change in v. So if we think about this, well, let's see, change in velocity. Change in velocity is acceleration. So if I want to accelerate, I need to speed up, slow down, or change direction. If I hit a softball with a bat, really I'm kind of doing all these things. At first I cause it to slow down, and then I try to change direction, then I cause it to speed up. So it's really doing all those things. So it definitely is accelerating. Real quick here, if I apply, in order to cause it to accelerate, I have to apply a force. So I need to apply a force, and I can't just have this force acting by itself. I have to have this force acting over a certain amount of time. That causes the momentum to change. But I want to show you guys something here. F times, if I bring my t over here, I get equals, yes. Well, this is acceleration. So really, our equation that we're going to be dealing with is just F equals ma. That's it. It's F equals ma. Just written a special way. And you might ask, well, why the heck would I want to write it this special way? Because I'm going to be able to explain lots and lots of things. Things like why you should wear your seatbelt. Things like why you want to follow through. Why the track outside is made out of rubbery, spongy material. Lots and lots and lots of stuff. But just so you know, F times t, this has a special name. This is called impulse. Okay? And so the force, okay, remember, and actually I'm going to write this down so we have it. So this is Ft equals change in mv. Okay? This, guys, is not just any random force. This is the force that causes the momentum to change. Okay? It's the force that causes the momentum to change. So if we're talking about hitting this with a bat, it would be the force from the bat. Okay? T here is not just any random time. T is the time that this force is applied. That the force which causes the change in momentum, So it's the time that the force, and again, the force which causes the change of momentum, is applied. So again, if we're talking back to hitting this with a bat, it would be actually the time that the bat is touching the ball. Okay? So force times time equals change of momentum. Now, just so you know, force times time has a special name. This is called impulse. So if I wanted to talk about a bat hitting a ball, I would say, well, when the bat hit the ball, the bat applied a force to the ball over a certain amount of time. Well, this force times time is called impulse. Therefore, the bat caused the ball to experience an impulse which changed the momentum of the ball. The change in the momentum of the ball equals the impulse of the ball because they have to be the same. I love it. Bye, kids.